Hi friends and students. Today I am going to discuss a problem from the complex numbers, right? And that is in four methods. The four different approaches to solve a single problem which has already appeared in previous IIT exam. Now the problem is this: Z is a complex number such that modulus of Z is equals to 1 and W is defined as Z minus 1 by Z plus 1. Then here we have to find out what is the real part of W, right? So what is the W? W is equals to Z minus 1 by Z plus 1. And what is the condition mentioned on Z, that is mod Z is equals to 1. The modulus of a complex number Z is equals to 1 and W is defined as Z minus 1 by Z plus 1, and here we have to find out what is the real part of W. Now the first method we are going to solve this problem is using the simple formula, that is real part of Z is Z plus Z bar by 2. So the first method we are going to use is real part of Z is Z plus Z bar by 2. Now I think you know this formula, everybody knows this formula. So you can see simply Z is equal to 5, suppose x plus iy, then what is the conjugate of this? Z bar is x minus iy. If simply you add them, what you are going to get? Z plus Z bar, which is equals to 2x. Now what is x here? X is the real part of Z. So what is the real part of Z formula? Real part of Z is equals to Z plus Z bar by 2. So this is the first formula I am going to use to solve this problem, right? Now the second method, what is the second method I am going to solve? Now here W is written in terms of Z. Now what I do here, I write this Z in terms of W, right? I am going to write Z in terms of W and I am going to utilize this mod Z equals to 1. Yes, we are going to use mod Z is equals to 1 each and every method, but here the difference is I'll write first Z in terms of W and then some using complex numbers formulae I'm going to solve this. So writing Z in terms of W, that is the second method. I call that, the method name is writing Z in terms of W. And the third method I am going to use is polar form of the complex number. You know what is the polar? You know what is the polar form of the complex number? Z is equals to R into cos theta plus I sin theta. In this, what is R? R is modulus of Z. R is modulus of Z. And what is theta? Theta is the argument of the complex number Z. So this I am going to use. Okay, in the beginning I'll start with this polar form, then I'll get this real part of W. Now the third method I am going to use is this, right? Whatever just now discussed, just now I discussed the polar form. Just this polar form I am going to use to solve the problem, right? So using polar form and some trigonometric identities we are going to use in it, because of here you can see in polar form you have cos theta plus I sin theta, so obviously we use some trigonometric identities. And the fourth method, which is very short solution to this problem, and you have to watch till to the end to know this application of a rotation theorem, or we call it as coni method, right? So I use coni method or the rotation theorem, that is nothing but the geometrical approach to solve this problem in easy way, right? So it takes only 2 to 3 steps to solve this problem with the fourth method. The fourth method is what? Geometrical approach, right? So you can understand the different concepts, right, how to apply to the single problem, and you can use these methods or concepts to solve some more problems from the complex numbers. And the important methods we are going to discuss here, because we have 4 methods, and in 4 methods we are going to use 4 different concepts, so you can understand these 4 different concepts in a single problem. Now the first method is what I told is I am going to use the real part of Z is equals to Z plus Z bar by 2, right? So but here we have to find out a real part of W, right? So here we have to find out real part of W. So real part of W, so according to this what we will have is W plus W bar by 2. If you want you can call this as omega, but I am calling this as W, right? So that's not important thing in this, whether you call W or omega. So according to this formula, real part of Z is Z plus Z bar by 2. I got here real part W, simply Z is replaced by W. Now if I write half into W is defined as already here z minus 1 by z plus 1. So I copy that W value z minus 1 by z plus 1. Now you see here, after that we have a W bar, means conjugate of W means conjugate of z minus 1 by z plus 1. Do you know conjugate can be separated in addition and conjugate can be separated in difference as well as multiplication division. So if I separate conjugate, I'll get z bar minus 1 bar by z bar plus 1 bar, or you can write, for the moment I am not separating the conjugate. So now you see 1 bar is a conjugate of a real number, because the 1 is a real number, conjugate of a real number is itself. That is what we have, z is equals to z bar if and only if z is real. If there is a real number, its conjugate is itself. So that I am going to use now half. After that I'll take LCM z plus 1 into z plus 1 bar. And one more formula you have is z into z bar is equals to mod z whole square. So here we have z plus 1 and here we have z plus 1 bar. So z plus 1 into z plus 1 bar is modulus of z plus 1 whole square. Now whenever you multiply, you separate the conjugate here, z bar plus 1 bar. There is z bar. What is that? Actually this one is z bar plus 1. Now so z into z bar, just after taking LCM, z into z bar plus, what do you have, z into 1, then we have minus 1 into z bar, then what you have, minus 1 into plus 1, which is minus 1. After that here we get z into z bar, z into z bar, then we get z into minus 1, which is minus, it is 1 bar, 1 bar is 1 only. So after that you get z bar minus 1. Now here you see this is equals to half into, is there any cancellation? So here you can cancel plus z minus z and minus z bar plus z bar. After that z into z bar, what I am telling is z into z bar is mod z whole square. So you use that mod z whole square, this one, and here we have one more. So mod z whole square plus mod z whole square, 2 mod z whole square, and minus 1 minus 2 by, in the denominator you have modulus of z plus 1 whole square. Right, modulus of z plus 1 whole square, sorry for that. Now what is the mod z value here? Mod z value is 1. So just you plug that value here, substitute that value here, put that value here, mod z is equals to 1. So 2 into 1, 2, here you get 2. So we get half into 2 minus 2 by mod z plus 1 whole square. Now this gives you 0. So I got now real part of w using the simple formula, real part of z is z plus z bar by 2. So what I got now, real part of w is 0. So this is the first method using the simple formula, real part of z is z plus z bar by 2, and we utilize this formula also, z plus z bar by 2. So try to remember these two formula, which are very important in the complex numbers. So many problems we solve using z into z bar is equal to mod z whole square. Alright. Now you see the second method. So in the second method, what I am going to do here, first I'll write this w is equals to z minus 1 by z plus 1. Right, now I write z in terms of w. To do that, just I'll multiply, cross multiplication, wz plus w is equals to z minus 1. From this I'll bring wz to the right hand side and minus 1 to the left hand side. So w plus 1 is equal to, after bringing this, I'll take z common, so that I'll get 1 minus w. So what is z from this? Z is equals to 1 plus w by 1 minus w. What I am going to do, I am going to utilize this now. Modulus of z is equals to 1. So here I want to bring that here. So what I do, I'll apply modulus on both sides. So if I apply modulus on both sides, I get modulus of z is equal to modulus of 1 plus w by modulus of 1 minus w. Because of mod can be separated in division. So but what we have here, mod z value we know 1. So this is equals to 1. So that implies if we do the cross multiplication, modulus of 1 plus w is equal to modulus of 1 minus w. In the previous method, what is the formula we used, one more, is z into z bar is equals to mod z whole square. So this z into z bar is equals to mod z whole square I am going to use here. Because of I don't have square here, first I will square on both sides. After squaring on both sides, I get modulus of 1 plus w whole square is equal to modulus of 1 minus w whole square. And you can apply this. Modulus of a z whole square is what? The complex number and its conjugate. So here the complex number is 1 plus w and its conjugate is 1 plus w bar. So here 1 plus w bar, you can separate 1 bar and w bar. So 1 bar is 1, so I write only w bar is equals to, we write 1 minus w, again 1 minus w bar using the same formula. So 1 bar is 1 minus w bar. Now just you do the regular multiplication. 1 into 1 plus w bar plus w into 1 plus w into w bar. What is w into w bar according to this formula again? Modulus of w whole square. So here we get 1 minus w bar minus w, and again w into w bar, which is mod w whole square. You can observe that both sides you can cancel mod w whole square as well as 1. Now bringing all the terms to one side, you get w bar plus w bar, 2w bar, and plus w. Here we have minus w, bringing to the left hand side you get plus w, 2w, so 2 common, w plus w bar equals to 0. So which is what? 2 into w plus w bar equals 0 means w plus w bar is 0. Now you know what is w plus w bar. Just now in the previous problem we used real part of z is z plus z bar by 2. So then what is z plus z bar is equal to real part of z. So what is w plus w bar? 2 real part of w is equals to 0, from which we conclude that real part of w is equal to 0. This concludes the second method. Right, so simply we wrote z in terms of w. Simply we wrote z in terms of w. After that we know modulus of z is equal to 1. That's why we applied modulus on both sides. After applying modulus on both sides, and again we used z into z bar is equal to mod z whole square many times in this. W into w bar here we have, w into w bar here we have. So z into z bar is equal to mod z whole square, and here mod z whole square we used again z into z bar. Right. Now we'll see the third method. Now what is the third method? I told you is we will use the polar form. What is the polar form of a complex number? Z is equals to r into cos theta plus I sin theta. Now in the beginning we discussed that here r is actually modulus of the complex number z and theta is the argument, right? So here r is mod z, you know, r is what? Modulus of z. But here it is mentioned in the problem mod z value is 1. So then z will become simply cos theta plus I sin theta. Theta is the argument of the complex number. Right. Now we use this cos theta plus I sin theta in w to get a real part of w. So w is equal to z. Z is cos theta plus I sin theta minus 1 divided by z plus 1. So cos theta plus I sin theta is z. Then we have plus 1. Right. So this real part I write together by taking minus common. I get 1 minus cos theta, so that I can use one of the identity from the trigonometry, and I write the real part separate, divided by, I let again real part this one, 1 plus cos theta together, right? 1 plus cos theta, and I have plus I sin theta. Now you see here I'll use some trigonometric identities as I told you in the beginning. So this is equals to minus 1 minus cos theta is 2 sin square theta by 2 plus I sin theta, right? Sin to a 2 sin a cos a, that is 2 sin theta by 2 cos theta by 2 divided by, what you have, 1 plus cos theta is 2 cos square theta by 2, 1 plus cos theta, and I into sin theta again, sin to a formula we are going to use 2 sin theta by 2 cos theta by 2. 2 sin theta by 2 cos theta by 2. Right. So now this is equals to, if I take minus 2 sin theta by 2 common from the numerator, 2 sin theta by 2 common, if I take this 2 sin theta by 2, if I take common, what you get? Minus 2 sin theta by 2. So it will become plus now sin theta by 2, and here we get minus I cos theta by 2 divided by, from the numerator, if I take 2 cos theta by 2, I get cos theta by 2 because of 1 cos theta by 2 is common here, and cos theta by 2 with the 2 is common, so we get plus I sin theta by 2. So now see here, 2 cancel, sin theta by 2 by cos theta by 2, I'll write minus tan theta by 2. Now see, what I am going to do here, I am going to multiply with the conjugate of this and divide with that. So what do you get here? Cos theta by 2 minus I sin theta by 2. Multiply and divide with the same complex number. So minus tan theta by 2, can you tell me what is the denominator you get? Cos theta by 2 plus I sin theta by 2 into cos theta by 2 minus I sin theta by 2, which is a plus b into a minus b, a square minus b square. So a square means cos square theta by 2. You get a square means what you get? Cos square theta by 2 minus b square means minus I square sine square theta by 2 you get. But here I square value minus 1. So it will become plus. So cos square theta by 2 plus sine square by 2 which is equals to 1. So denominator is 1. So I'm not going to write that one now because of by 1, right? So you can leave it. Now what about numerator? Now numerator you multiply sine theta by 2 into cos theta by 2. What is that? Sine theta by 2 cos theta by 2. So actually I have to write numerator. So here we don't have that much space. So you adjust this sine theta by 2 into cos theta by 2 minus what you have sine theta by 2 into I sine theta by 2 which is I sine square theta by 2. Then what you have minus I cos theta by 2 into cos theta by 2. So minus I cos square theta by 2. Then what you will have minus I cos theta by 2 into minus I, minus into minus plus I square, but I square is minus 1. So minus cos theta by 2 into sine theta by 2. Now almost the problem is finished. So something I wrote wrong in the word. Sine theta by 2 into cos theta by 2. I forgot to write here cos theta by 2. Can you see sine theta by 2 cos theta by 2 is cancelled. And if you take minus I common, you get sine square theta by 2 plus cos square theta by 2 which is 1. So at the end you get plus I tan theta by 2. Can you see here? It is a purely imaginary number. There is no real part. It's purely imaginary. So it is purely imaginary means there is no real part means real part is 0. Whose real part is 0? We started with the W. So real part of W is equals to 0 which concludes the third method. Right? Though it's a lengthy, just I want to tell you we can use Z is equal to R into cos theta plus I sin theta. So polar form is also one of the useful form to solve some different type of problems. So keep in mind this mod amplitude form or polar form, that is Z is equal to R into cos theta plus I sin theta. Right. Now we will jump into the fourth method. Now the fourth method I told you is we'll use the geometrical approach, rotation theorem, or we call it as a coni method, geometrical approach. Now let us suppose, first can you guess what is this mod z is equals to 1 represent? Now here we have mod z is equals to 1. Now mod z is equals to 1 actually represent a circle whose center is origin and the radius is, and what is the radius? Radius is 1. Because of it is in the form of modulus of z minus z naught is equals to r. Here z naught is 0 which is origin, r is the radius. So let me draw a circle. So here the rough sketch of the circle, it's not that much good drawing, but let us suppose this is a circle and whose center is here. Now because of its radius is 1, this is 1, I can say 1 comma 0 or 1 minus 1 on real axis. This is real axis. Because of it is complex numbers, we call it as real axis, and we call this one as imaginary axis, and the plane we call is organ plane. So in this organ 1 minus 1 real, and mod z is equals to 1 means z can be any point on the circle. So it is moving on the circle. Let us suppose somewhere I have z here. Now if I join this z and minus 1, the complex number z if I join with the 1, can you tell me if I say this is point A and this is a point B, AB is the diameter of the circle and this is the semicircle. In a semicircle angle is always 90 degrees. So this is angle of a semicircle which is 90 degrees, or I can say pi by 2. So if you use this rotation theorem or coni method, what it says actually, if you have z2 minus z1 by z3 minus z1 can be written as modulus of z2 minus z1 divided by modulus of z3 minus z1 and e to the power of I alpha. What is alpha? Alpha is angle between the line joining this z1 z2 complex number and z3 z1 complex number. See, whenever you rotate the line which you have in the denominator in anti-clockwise direction to coincide with this anti-clockwise direction, if you measure, this alpha will be positive angle, and if you measure in a clockwise direction, this angle is going to be negative. Okay, and you have to rotate the denominator vector. So if you don't know about the rotation theorem or coni method, already I made a video on this. Okay, there is a full explanation on this, how to use it and what is actually coni method and rotation theorem. So you can watch that video if you don't understand this. Okay, now I'll explain the problem actually. Okay, now this is now how to use this rotation theorem. Now let me see. Here we have in the denominator z plus 1, so you have to rotate the z plus 1 to reach z minus 1. This is z minus 1. So to reach z minus 1, if you rotate, it is in anti-clockwise. This is the direction you have to rotate. So you have to rotate in anti-clockwise direction. So what you get here, z minus 1 by z plus 1, which is equals to, see, if you know the rotation theorem, no need to write all these things. No need to write all these things. Directly jump into writing z minus 1 by z plus 1 is equal to modulus of z minus 1 by modulus of z plus 1. Just we write directly this step. Okay, e to the power of I alpha. What is the angle here? We have pi by 2. Now what is the e power I theta? Cos theta plus I sin theta. So modulus of z minus 1 by modulus of z plus 1 into cos theta means cos pi by 2. Cos pi by 2 is 0. Leave it. I sin pi by 2 and sin pi by 2 is 1. So can you see this? This is a real number with I. So it's a purely imaginary, because if it is in the form of I into some real number, ik form, it is in the form of ik, so it's purely imaginary. So therefore there is no real part. So there is no real part means real part of z minus 1 by z plus 1 is 0, means real part of w is 0. So that what we want and what we got in the previous three methods, right? So this is the very simple short solution for this problem. Just you apply the coni theorem, you got a purely imaginary number, there is no real part, so therefore real part of w is 0.